right? We have learned how to make a covalent bonding in nitrogen, how it is made in oxygen, how it is made in hydrogen and chlorine. In chlorine, we have one single covalent bond. In oxygen, we have two bonds, which is also known as double bond. In nitrogen, we have triple bond, right? So now we'll study another compounds. For example, HCl. HCl is your hydrogen chloride. Okay, so in hydrogen chloride, you have two elements, hydrogen and chlorine. So you have to write down the valence electron of both these elements. Hydrogen is 1 only, right? And chlorine is 17. Its configuration would be 2, 8, 7. Okay. Now in covalent bonding, you have to represent only the valence electrons, which are also known as outermost electrons. So this cross is the electron of hydrogen, which is 1 only. And these dots are your electrons of chlorine, valence electrons of chlorine 1, 2, 3, 4, 5, 6, and 7. Okay. So I told you that there are two elements in the periodic table, hydrogen and helium, which want 2 electrons to become stable. Otherwise, all the other elements want 8 electrons in their valence shell to achieve stability. Hydrogen only needs 2 electrons. Okay. So this hydrogen, it will share 1 electron of this chlorine to become stable. Now it is stable. And chlorine also shares 1 electron of hydrogen to become now 8 electrons, valence electrons. So chlorine is also stable. Okay. So there is a sharing of electron. Okay, there is a sharing of 1 pair of electron. Or you can say there is a sharing of 2 electron. 1 pair means there is a sharing of 2 electrons. Okay. So the chlorine atom, it shares 1 electron with the hydrogen atom. Both have stable arrangement of electrons in their outer shells. 2 is for hydrogen, like the helium atom, which also needs 2 electrons to achieve stability. And 8 for chlorine. Okay, every other element wants 8 electrons in their outermost shell, like the other noble gas atoms. So this bond is made like this, HCl, right? Only single covalent bond because only 2 electrons are shared, or you can say only 1 pair of electrons are shared. Is it clear?
Yes, ma'am.
Now see for water, how to make the covalent bonding in water. So I told you have to write down the atomic number and electronic configuration. So for hydrogen, it is 1 only. There is only 1 electron in hydrogen. And for oxygen, it is 8, which is equal to 2, 6. 6 valence electrons you have to show in the structure. So 1, 2, 3, 4, 5, and 6. These cross are my electrons of hydrogen. So hydrogen shares 1 electron. This hydrogen shares 1 electron of oxygen to become 2 electrons, okay, to complete the duplet. And this hydrogen also shares 1 electron of oxygen. And oxygen needs 2 electrons to complete stability, right? So it shares 1 electrons of this hydrogen and it shares another electron with this hydrogen. So the oxygen atom, it shares electrons with the 2 hydrogen atoms. Now all have a stable arrangement of electrons in their outer shells. Hydrogen is also having 2 electrons and oxygen is also having 8 electrons. Okay, so this is how covalent bonding is made. So you can write this structure as H2O. Okay, only one single bond is there because hydrogen, there is only sharing of 2 electrons, or you can say pair of electrons. Okay, is it clear? Okay, so draw it. Draw the covalent bonding in hydrogen chloride in water. Draw it on your own, and if you find any difficulty, then please let me know. If you have any doubt in this, then please let me know, okay? Because you have to make covalent bonding of other molecules also.
Okay.
Now, these are your homework question. You have to draw the covalent bonding in methane, that is CH4, okay? And in methane. So you can take a screenshot of this slide. I'm explaining how to make it. So first of all, as I told you, first step is to write down the electronic configuration. Carbon, atomic number 6, electronic configuration is 2, 4. Hydrogen is 1 as always. So you can see there is only one electron of hydrogen, one here also one, here also one. And carbon is having 4 electrons which are represented by a dot. 1, 2, 3 and 4. Okay. And I told you that hydrogen needs 2 electrons to complete its octet and carbon needs 8 electrons in its valence shell, right? So the carbon atom, it shares electrons with the 4 hydrogen atom, and sharing of electron is what? Nothing, it is a covalent bond. So all now have a stable arrangement of electrons in their outer shells. 2 for hydrogen, it is also happy, and 8 for carbon. Okay. Now shape is very important. If I ask you what is the shape of methane, so you have to write it is tetrahedral in shape. Why tetrahedral? Because you can see this diagram. Here carbon is having 4 bonds. Okay, 4 is known as your tetra. Because the 4 pairs of electrons around carbon repel each other and they move as far apart as possible. Okay, so this structure is because of that these pairs of electrons, they repel each other and they move as far apart as they can from each other. The angle, which is very important. If I ask you what is the angle in methane, bond angle in methane, so it is 109.5 degrees. Okay, it is also 109.5 degrees. It is also 109.5 degrees. Okay, so from this slide, what you have to remember, how to draw the covalent bonding in methane. I hope you can do it. If I ask you what is the shape of methane, you have to answer it is tetrahedral.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
If I ask you what is the bond angle in methane, then you have to answer it is 109.5. Is it clear to you? Okay, so please make it in your copy. Don't forget. Okay. Next is your ammonia. Draw the covalent bonding in ammonia. So the first step is write down the electronic configuration of nitrogen. Atomic number is 7. Configuration is 2, 5. Hydrogen is 1. Very simple. Okay. So this cross is my electrons of hydrogen, only 1. And you have to make 5 electrons of nitrogen. 1, 2, 3, 4 and 5. Okay. Now nitrogen needs how many electrons to complete its octet? Tell me.
Sorry?
I'm asking nitrogen needs how many electrons more to complete its octet?
Sorry, ma'am, I'm not getting you.
I'm saying that here the electronic configuration of nitrogen
Yes.
is 2, 5.
Yes.
So how many more electrons does nitrogen need to complete its octet, to complete the stability, to have 8 electrons in the... Yes, 3 electrons. So these 3 are shared with this hydrogen 1 and this hydrogen 2 and this hydrogen 3, and 2 electrons, they will remain free as lone. So read this line that each nitrogen atom shares electrons with 3 hydrogen atoms. So all 3 atoms now have a stable arrangement of electrons in their outer shell. 2 hydrogen needs always 2, okay, and 8 for nitrogen. If I ask you what is the shape of nitro ammonia, so you have to answer it is pyramidal. So write it in the bold language or use it your highlighter here. The shape of ammonia is important. It is pyramidal. Next is your methanol. Draw the covalent bonding in methanol. So draw all the atoms, carbon, H3, OH. Then write down the electronic configuration. Hydrogen is 1, oxygen is 2, 6. Okay. So you can here see hydrogen is completing its duplet of electrons by sharing 1 electron from carbon. And carbon is completing its octet by sharing 3 electrons from hydrogen, right? And 1 electron from oxygen. Oxygen is also completing its octet. It needs 2 electrons, right? Oxygen needs 2 electrons. One it is sharing from this hydrogen and one it is sharing from this carbon. Okay, so the carbon atom shares electrons with 3 hydrogen atoms and 1 oxygen atom. And what is the shape? You can see, look at the shape of the molecule. It is somewhat like methane, but so you do not have to write down this point. Not important. So you just the important point is how to make the covalent bonding in methanol, and you have to satisfy all the elements in the methanol are completing its stability. Okay, hydrogen needs 2 electrons and every other element needs 8 electrons. Is it clear? Is this clear? Am I audible?
Yes, ma'am, you're audible.
Okay, so any problem in the covalent bonding of ammonia and methanol?
No, ma'am.
So draw it, and if you find any problem, then please do let me know. Draw it in your notebook.
Okay. Ma'am, please give me a moment. I'll be right back.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Done. Now, the another example of covalent bonding is in carbon dioxide and in ethene. So, C for carbon dioxide, how to make the covalent bonding. So, carbon dioxide is your CO2. So, write down the electronic configuration of carbon, which is 2,4, and oxygen, which is 2,6. So, you have to represent these 4 electrons of carbon, which is represented by a dot 1, 2, 3, and 4. Then you have to make 6 electrons for oxygen, which is represented by a cross 1, 2, 3, 4, and 5 and 6. Okay. So you know that oxygen needs 2 electrons to have 8 electrons in the valence shell, and carbon needs 4 electrons to achieve stability, right? So this carbon, which is having 4 electrons, actually, it shares its 4 electrons with these 2 oxygen atoms, 2 from this and 2 from this. That's why carbon dioxide is like this. We write carbon dioxide like this, C double bond O and double bond O. If I ask you about its shape, so you can see it is a linear molecule because the two sides of bonding electrons, they repel each other. They move as far apart as they can. So the shape is linear molecule. So it is not a single bond, it is a double bond because there is a sharing of 2 pair of electrons in this. Similarly for ethene, C2H4, carbon have 4 electrons, hydrogen have 1 electron. Hydrogen share its 1 electron with this carbon, and this carbon it shares 4 electrons with this carbon to achieve stability, to have H electrons in its valence shell. Okay, so it shares carbon, it shares 2 with the 2 hydrogen atoms and 2 with these another carbon atom. So we have a carbon-carbon double bond. So this molecule is shown like this, okay, because there is a sharing of 2 pair of electrons. So one pair is this and one pair is this. Is it clear?
Yes, ma'am.
Okay, so I hope by now you can make covalent bonding in any covalent compound. So the method is same, you just have to practice. So take a screenshot of this slide, write it after the class.
I've taken.
This is your homework question. Draw a diagram to show the bonding in carbon dioxide. And why is the carbon dioxide molecule straight and not bent like the water molecule? So this covalent bonding you can easily show for carbon dioxide. And why it is not bent? Why it is straight? Because here it is written that the 2 sets of bonding electrons repel each other. They move as far apart as possible. That's why it is a linear molecule and not bent. So this is the answer to that question. Okay. So now,
Touched.
yeah. Now we have studied 2 types of bonding, 2 types of compounds, ionic compounds and covalent compounds. So metals and non-metals, they react together to form ionic compounds. For example, NaCl, MgCl2. Okay, where sodium is your metal and chlorine is your non-metal. Magnesium is your metal and chlorine is your non-metal. But non-metals react together to form covalent compounds. Okay, like CO2 we have made, and we have made another molecules also, ammonia. So these are my non-metals. Carbon, oxygen, nitrogen, hydrogen, they are my non-metals. So when non-metals react together, they form covalent compounds, and when metal and non-metal react together, they form ionic compounds. Is the difference clear?
Yes, ma'am.
Write it down.
Done.
Now here, see this. This is my sodium chloride. Okay, sodium chloride, that is NaCl. Okay, so here the ions are held in a regular lattice like this. So NaCl is not that you have only one Na plus ion and you have only Cl minus ion. No, you have a complete 3D structure. Okay, they are held together by strong ionic bonds. This lattice grows in all the directions. It gives a crystal of sodium chloride. Crystal of sodium chloride, it is just a rock salt which you eat. This one is magnified 35 times. So this is the crystal of salt. Okay, it is magnified 35 times. Now the crystals look white and shiny. Your salt, we add them to food as salt to bring out its taste. So if I ask you that which type of compound is sodium chloride, is it an ionic compound or covalent compound?
Please repeat.
I'm asking which type of compound is sodium chloride? Is it ionic or covalent?
Ionic.
Yes, it is ionic because it is formed by transfer of electrons and not sharing of electrons. Also, sodium is a metal here and chlorine is a non-metal here. So the bond between a metal and non-metal is ionic bond. Okay. And if we have a bond between two non-metals, it is your covalent bond. So from this slide, you can note down this thing that sodium chloride, it is a typical ionic compound, and this point. That in
Okay.
sodium chloride, ions are held in a regular lattice. They are held together by a strong ionic. Okay, so you can see here that this is positive is my Na plus, this is Cl minus, this again plus, this Cl minus. It is in the shape of a cube. So many crystals combine together to form this 3D arrangement. Okay, so write down.
Yes.